Okay, so I'm going to be showing you a synchronous machine right here. This is a synchronous motor. It has slip rings and it has a wound rotor. So this machine right here allows us to input DC onto the rotor itself. And unlike most induction motors, it allows us to actually bring the rotor into synchronous speed with the rotating magnetic field. So our rotating magnetic field, which is 60 hertz, with a 6-pole motor, we're going to be rotating at approximately 1800 RPM. So we're going to put our 3 phases into this watt VAR meter, watts measuring our power consumption, and then VARS, the volt amp reactive. We bring our 3-phase down into our 1, 2, and 3 terminals of our motor, and then we have our 4, 5, and 6 connected together, so a Y-type connected motor. And then we're going to turn this on, and you can see how much power the motor is pulling and whether it's an inductive or capacitive load. So let's take a look on startup. So we started up the motor. We start up the motor, and as you can tell, we have a purely inductive load. The meter is pegged right now with the VARS, and you can see we're pulling about 60 watts. This is with no load on the motor itself. We could put a load on it and it would be pulling more, but right now we have no load on it. So what we're going to do is there's a physical switch because we have to start the motor with DC not connected to the rotor and get the motor going like a normal induction motor. So right now we're going to actually put the DC onto the rotor, and you'll see that we're going to flip. So now our motor's acting like almost like a purely resistive device. And as you can tell, the watts have gone down to about 20 watts. So we've cut our power consumption way down. As you can tell, right now our motor's just humming along, and it's in synchronous speed with the rotating magnetic field of 60 hertz, 6-pole motor. So we're pulling 1800 RPM. And right now I have a variac, so I can increase or decrease the DC that is being provided to the rotor. So right now I'm going to increase the DC that's going on to the rotor. And as you can tell right here, we're going from being a resistive load to being more and more capacitive. If I take that DC away, I'm bringing the motor out of synchronous speed, and now it's relying on the slip of the rotor to induce onto its rotor itself. And as you can see, the watts have gone up slightly. So I can dial that in with my the variable power supply right there, and bring my motor into equilibrium. So there you go. That's a synchronous motor right there, and we're just measuring the reactive element that comes with most induction machines, like a transformer or any kind of 3-phase, single-phase induction motor. Well, with this one, we can actually put DC onto the rotor itself and synchronize the rotor with the rotating magnetic field, and now the motor's in neither capacitive nor inductive.